Okay, so this is the extension of the part 2 of the LoRaWAN tutorial, because the recording software that I have has a limitation of 15 minutes. Okay, so for this video, in the last video we have covered the communication between the node device to the Think network, and all the information, the payload of the node device are all zeros except for byte. I think it's byte 8. The 8th byte is FE. The rest are all zeros. Okay, so for these videos, we're going to do some modification to the firmware, and we're going to send some data and receive some data to and fro from between the Things network and the node device. Okay, let's go to, first we right now in this screen you'll see that the node device that we have, the node device is sending data every 10 seconds to the Things network. Okay, so you update every 10 seconds, 10-second windows, and then you update here. Okay, so you can also let me show you. You can also uplink from the Things network to the node device. So how do we do that? Oh, sorry, it's downlink from the Things network to the node device. Okay, so how do we do that? Let's take a look at the code itself. Okay, if we go to the main.c, and we search for LoRa receive then we receive data. Yeah. Okay, so the function to receive the data is LoRa_RX data. So first thing that you check is the port. Okay, let's say we look at this. So what is the LoRaWAN app port? We look at the definition. It's port 2. Okay, it's port 2. So if it's port 2 and the receive buffer is equals to 1 byte, okay, 1 byte. If the LED state on equals to, okay, the byte that we receive, only 1 byte, and end with 1. If the data is 1, you turn on the LED. If the data is 0, it will be off. Okay, so current status is off. We don't see the blue LED turn on the screen. I'll put a little bit closer to the screen. So it's off status. So to turn on, first we have to select the port 2, and we have to send 1 byte, and the byte value is 1. So we go to, let me arrange the windows. Okay, so we simulate the downlink. So we select port 2, and if we send 0, 1, because it has to be in the hexadecimal. If 0, 1, you will turn on the LED, the blue LED. 0, 0, you will turn off the LED. So press send, and it's now in the queue. Okay, now it's turned on, and it sees that packet received on port 2 LED on, and then continue with the receiving and transmitting. It's still on. So now I'm going to turn it off. So I'm going to send it still port 2. I send 00. And when I send, it takes a while. So you may miss a few frames. So we have to take a few cycles. Okay, so now it's received on the port 2 and it's turned off. Okay, let me do it one more time. I send a 1. Okay, now it's turned on. And I'm sending a 0. Because it's updating every 10 seconds and it may not be transmitted on the following window. Okay, now it's turned off. Okay, to increase the frequency of transmission, you can go to the code here and look for still in the main, and you see the application transmit duty cycle. Now it's set to 10,000 milliseconds, which is 10 seconds. So if you want to increase the speed, let's say 2 seconds. Okay, 2 seconds. Save and compile. Okay, we load the program again. So programming in progress. Okay, it's done. So I'll press the reset button, and now we look at both the things network data. Okay, now it's joined. If you see, you can see from the status in the Terraton, and it's updating now every 2 seconds, much faster. Yeah, every 2 seconds. You can see the timing here. Okay, let's see. 21, 4 seconds, 4 seconds, and 4 seconds. Okay, it's updating every 4 seconds, which is faster than previous. I think there's a limitation on the speed that you can receive and transmit. Okay. So anyway, I'm going to change back to 10 seconds. I need to compile. Okay, and load the program. Okay, it's done, and I will press the restart button. So now the loading, the transmit frequency will be now back to 10 seconds. Okay, now it's joined. Okay, this is the first byte. That is first payload that we received from the node device. Okay, this is the second one. So every 10 seconds, you receive the data from the node device. So next one will be 13. Yeah. So now we are back to the 10 seconds time frame. Okay. Okay, now since the payload here is not meaningful, so we're going to change the payload to something that is more meaningful. Again, we go to the code and we look for send. Okay, so the function to send the data from the device to the things network is the set. So if you look below, you cascade the information on the pressure, temperature, humidity, battery level into a stream of buffer. So the buffer is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 bytes. The first byte is the status of the LED, the blue LED. The second and third is the pressure. Fourth and fifth is the temperature, humidity, 2 bytes, and battery level 1 byte, and the rest will be 0 byte. So 1 byte, 2 byte, 2 byte, 2 byte, 1 byte, and the rest are just empty. Okay, so for example, I'm going to send some data. Instead of 0, I'm going to have a pressure, just arbitrary numbers in hexadecimal. So this is a hexadecimal value, 1212. Temperature is 0A, 0A, humidity 2233, and battery level 64. 64 is 100%. So let's compile and load the program. Okay, it's going to finish. Okay. Okay, I'm going to press the reset button again. Okay, there's some communication and you should join the network. Okay, join. And the first byte is, let's decode the signal, the payload. From the code. Okay, so the first byte is the LED status, which the LED is turned off, so it's 0. Then the following 2 bytes refers to the pressure, so it's 1212. And the next 2 bytes is temperature, which is 0A, 0A, which is 0A, 0A. And humidity, we are sending 2233, 2233. And the battery level is 64. And the rest of the data are all 000. Okay.